Hi guys, I'm back again today with another video, and today we are checking out the insane scale of Europe's new mega tunnel. I don't know if this is the one yesterday or is this a different one, but we're gonna find out. So before we start, don't forget to subscribe, click the bell button, and let's get it.
This is one of the world's biggest construction projects. A $7.5 billion feat of engineering that's going to transform travel across an entire continent.
And it's happening here, on the quiet German island of Fehmarn.
Let me explain. This is the ScanMed corridor. It's the northern access of the Trans-European Transport Network, and it spans nearly 5,000 kilometres from Malta in the Mediterranean to Finland's icy tundra. Along the way, it drills through alpine mountains and crosses the sea.
But follow the route north and something strange happens. Instead of being able to go straight on to Sweden, you have to take this 500-kilometre detour through Denmark. And it's all because of this, a stretch of water between Germany and Denmark called the Femern Belt. So let's just get this straight. There's currently a 55-kilometre tunnel being dug through a mountain in Austria. There's an epic bridge and tunnel linking Denmark and Sweden. There's another massive bridge linking two Danish islands. But we can't get over this. It might not look like much, but this unassuming stretch of water has thwarted the plans of the world's best engineers for decades. Until now.
This is one of Europe's largest construction sites.
I dag gik arbejdet med Femern Bælt-forbindelsen ind i sin næste store fase.
It will be the longest immersed tunnel in the world.
There's no instruction manual for building anything like this.
The fastest route between Scandinavia and Central Europe.
Nicht unumstritten ist, ob die positiven Folgen dieses Projektes überwiegen. Umweltschutzverbände sehen das sehr kritisch.
I mean, the risk is that people never stop. Maybe they just pass through.
What are your concerns with this scheme?
They're destroying our nature.
We're building the Femern Belt Tunnel between Denmark and Germany.
You might not have heard of Fehmarn or its tunnel, but this is one of the most technologically advanced mega projects on the planet. Absolutely enormous, like an aircraft hangar in here. And it kind of epitomises the power of construction and its ability to change our world. Absolutely incredible. You get those moments in infrastructure where they nail both the engineering and the architecture and they kind of come together. I saw it on the Elizabeth line. Did it really well. London's new railway. Getting the same feeling here. I am currently driving over the Øresund Bridge. One of the world's most incredible feats of engineering, probably one of its best infrastructure projects. It's this structure that links two countries, it links Denmark and Sweden. This is where the whole story starts. It's when this was being planned that Sweden had a big idea. So right now, to get from Sweden down into Central Europe, you have to catch a train here at Malmö. That takes you over the Øresund crossing to Copenhagen, where you have to change onto another train that eventually takes you over to Hamburg and down into Germany. Even on a high-speed train, that takes you 5.5 hours. And for freight trains, it's even slower. Germany is Sweden's second biggest export market, so that's a huge deal. The Swedish government saw a shortcut here at the Femern Belt. So they said to Denmark, we'll help you build the Øresund Bridge if you look into the possibility of a new fixed link in the waters behind me. Fortunately, that request wasn't as outrageous as you might think.
So here's Denmark, and this is the German island of Fehmarn, which gives the Femern Belt its name. Now, there's been talk of creating a railway between Hamburg and Copenhagen since the 19th century, but nothing really happened until the 60s when a bridge was built here. That route was then extended to a new ferry port at Puttgarden, bringing trains right up to the water's edge. Amazingly, the trains were then loaded onto ferries and carried over the Fehmarn Belt and onto Denmark. The whole thing was pretty slow. Diesel trains weren't as fast as the ones we have today, and the ferry itself took around 45 minutes. For years, people talked about the idea of a fixed link between these two countries, a bridge or a tunnel. But it wasn't until Sweden threw down the gauntlet that things got really serious. It was way back in 2008 that the Danish and German governments first signed a treaty to start work on the Fehmarn Belt fixed link. There was a lot at stake. The idea was to replace the ferry with a new permanent crossing. It would have a 4-lane motorway and 2 rail lines serving both freight and high-speed passenger trains. And the whole thing would be funded by Denmark, who would also collect the toll fares and run the onshore businesses. Separately, Germany would upgrade the route from Puttgarden to Lübeck to allow for the new trains and traffic to pass through. That would also involve building another, much shorter tunnel to the German mainland, here at Fehmarn Sound.
It would be a once-in-a-generation upgrade of the transport network. The Hamburg to Copenhagen corridor would be transformed into a high-speed rail and road route. The Swedes would get their shortcut to the continent. A massive detour would be wiped off the Scanmed corridor, and that in turn would transform the wider trans-European transport network. The only thing that stood in the way was the water.
The most obvious solution was a bridge. This is what they came up with, a 3-kilometre long cable-stayed bridge sitting 65 metres above the water so that ships could still pass underneath. It probably reminds you of the Øresund bridge, and it would have been similar, but nearly 3 times as long. And that's where the problems began.
You see, the Fehmarn Belt is pretty awkward. From there to there is just under 20 kilometres, and that's further than the Øresund bridge had to cross. Also, the depth of the water out there in the Baltic Sea is just over 40 metres, and the soil conditions aren't great for building on.
That all meant the bridge would have needed spans of over 700 metres, and nothing like that has ever been built before for a combined road and rail bridge. The plan was for 3 huge pylons, each just under 300 metres tall. The foundations of those would have to be built at sea in depths up to 25 metres. Throw in poor soil conditions and a busy shipping lane, and you have an engineer's idea of hell. Then, as you'll have gathered from my trip on the ferry, there's the wind. Now, some of the world's biggest bridges, the Øresund Bridge, the Çanakkale Bridge in Turkey, or the epic Hong Kong-Macau crossing, all share a common trait. They all, more or less, run horizontally from east to west. A bridge crossing the Fehmarn would have had to go from north to south, meaning that every train, truck, car and YouTuber trying to make a video would get battered by the prevailing winds blowing from west to east.
So, after careful consideration of the risks of a cost overrun and the technical complexities of construction, the bridge was firmly ruled out. If you can't go over, you've got to go under, but it's okay, because the Fehmarn Belt is a pretty good place for a bored tunnel.
Now, there's a few reasons why bored tunnels are great. First off, they don't disturb anything above ground. That's why they're usually used for underground railways in cities, but that's also great for a place like Fehmarn, which has a delicate ecosystem that could take years to recover from all the disruption caused by building a bridge.
They're expensive, but they become more economical the further you go. So the team looked into the possibility of a bored tunnel under the Fehmarn Belt. But that's who hit a snack.
Bored tunnels are dug by a tunnel boring machine, or TBM. The width depends on the TBM, but something like London's New Elizabeth line used machines around 7 metres wide. They're good for something like an underground railway because you have 1 track per tunnel. But Fehmarn needs a railway, motorway and an access tunnel. That could mean boring 5 tunnels at 5 times the cost. And that's not all.
Very little of a train's surface area actually sits on the track, and because its wheels are made of steel, or at least they are in real life, there's very little traction. On flat tracks, that's great. It's one of the reasons why trains are so fast and efficient. But going uphill becomes a bit more challenging. The average mainline train can drive upwards by 2.5% or 1 in 40, meaning that for every 40 metres of track, the train can move upwards by 1 metre. The Fehmarn Belt tunnel sits 40 metres deep. Any bored tunnel would have to be 10 metres below that and incredibly long in order for a train to travel into it, pass under the ocean and then successfully climb out again the other side. A shorter tunnel would create a train track that's incredibly steep, and any train probably wouldn't make it. So a bridge was too difficult, a bored tunnel was too expensive, things weren't looking good. Thankfully, there was one more option on the table, the immersed tube tunnel. Now, I know what you're thinking. Finally, another shot of Fred Mills on the beach, a freezing cold beach in the Baltic. The way this tunnel's built is actually pretty straightforward. First of all, you create your tunnel segments in a nice dry factory on the land. Then, instead of digging a deep tunnel underneath the seabed, you just dig a trench in the bottom of the seabed. Then you take your tunnel elements and lay them in one by one, sealing them together as you go. Then you cover the whole thing over. And hey presto, you've got a tunnel. It's a great solution for a place like Fehmarn. You don't have to build a bridge where you're going to be subject to the wild weather and the ocean. You don't have to dig a deep tunnel, which wouldn't really work for a train. And shipping lanes above stay open. Keep driving over the Øresund bridge and you suddenly hit a man-made island and then drop down under the ocean. I'm driving under the water right now. This is very, very cool. This is the Drogden Tunnel, which is itself an IMT. This is like a preview of what's going to be built down at Fehmarn. Now, some people have asked, why go through the hassle of building a tunnel, then a man-made island, and then a bridge up here at the Øresund crossing? And it basically exists because of Copenhagen Airport, because of the restrictions to do with height around that.
IMTs are usually used for fairly short distances like rivers and harbours. This is one of the longest IMTs in the world, and it's only 4 kilometres. The Fehmarn Tunnel will be 5 times longer, making it an immense feat of engineering.
20 kilometers?
So, how the heck do you build something this big?
Well, it all starts here. I'm currently standing in Rukaiya on the Danish side of the Fehmarn Belt and on one of the biggest construction sites in Europe. It's all run by the Danish state-owned company Femern AS, and this place is so big that it's taken them 2 years just to build the work area. The place is a hive of activity. There's a village for 1,300 workers, a specially built harbour for material deliveries, and the northern portal where the tunnel will come up to the surface. But the star of the show is easily the massive building behind me. This is the factory where the tunnel segments are going to be made. It's one of the biggest factories ever built in Denmark, altogether covering 500,000 square metres. That's around 200 football pitches.
These buildings are vast because they need to be. The 89 enormous concrete tunnel elements that will be constructed here will each be 220 metres long and 40 metres wide. That's so they can fit 2 railway tunnels, 2 motorway tunnels and a service route all side by side. Building an IMT tunnel under the ocean works like this. Initially, the team constructed a new work harbour on the coast so that materials could be brought to the site by sea. That's enabling them to build these enormous tunnel factory buildings that will contain 6 production halls in total. Once fully up and running, these factories will be on 24 hours a day, 7 days a week, for 3.5 years. Aggregates and materials will be delivered to the work harbour and then taken by conveyor belt to the factories. In here, each of the 89 tunnel elements will be cast, but they're so big they're actually formed of 9 segments.
Actually, it takes 36 hours to cast one segment. It has a very, very detailed plan, like if you are baking an enormous advanced cake. It has to be the right temperature before you go to the next layer, and not too much, not too cold, not too hot, not too wet, not too dry. And then it's in 36 hours they have made one segment, and we have to make sure that the concrete are running for all 36 hours.
Once a tunnel element is constructed, it'll be rolled out of the factory and taken here to the upper basin, where huge doors will close behind it. Rather like a lock, the basin will then be flooded, ballast tanks will enable the element to float, and tugboats will move each element down to the lower basin and then out to sea.
They're then taken out here, where the trench they're going to sit in is currently being dug.
So cool.
Now, that's the first challenge this project throws up. IMTs normally sit 20 metres deep. This is 40 metres.
Once the trench is ready, the next step of getting a 73,000-ton concrete tunnel element to the bottom of the ocean isn't too difficult. Its ballast tanks are simply flooded, and gravity does the rest. But getting each element into the right place is much harder. Along the entire 18-kilometre route, they have to land within 15 millimetres of their targets. To make the whole thing watertight, the tunnel elements are fitted with something called a Gina gasket at one end. Once laid in the trench next to another segment, the water is pumped out of the space between the two bulkheads, creating a partial vacuum. This pulls the two concrete elements together, and the Gina gasket gets squashed in between them, creating a seal. Once all the elements are in place, the trench is backfilled and the tunnel is covered in gravel to protect it. At this point, nature takes over and eventually covers the gravel bed with sand. Then there's just the small matter of fitting the whole thing out with lighting, ventilation, a motorway and a railway before the whole thing opens in 2029. That's basically it.
It's so crazy how human beings are so gifted. Like, we are so, I don't know, just wonderful creations, right? Super smart. When we work together, we can accomplish a lot of things. Super smart. Like, there are people looking for cures. There are people doing this genius engineering, and it's just so beautiful to see. And I'm so fascinated about the human brain, because I'm like, where's my brain? Like, hello. But hey, props to the people who got them and using it for good stuff, because this is some craziness. Like, there's no day that I react to this and I'm not like mind blown. I'm like, what are these people? Are they humans or are they robots, right? So props to them.
It's easy, right?
Wow. It's absolutely epic. The size of it is huge.
On paper, the process seems logical and practical, but seeing it up close, you can't help but feel dwarfed by the immense scale of both its ambition and its engineering.
Well, this is production hall B, which is one of 3 production halls where we will be casting the tunnel elements for the femern tunnel. This one is the furthest ahead of the 3. It's 98% completed. Right now, as we're entering, they're just busy setting up the internal cranes, the formworks, and all the equipment we need for casting the elements.
Absolutely enormous, like an aircraft hangar in here.
It is. You could easily park a 747 or 2 in here.
Wow.
This has actually been pretty fast. We've been working on the factory site here at what we call the PFA, the production facility area, for about a year. So everything you see here is basically shot up out of nowhere over the last 12 months.
What keeps these engineers awake at night is not whether their foundations and calculations are correct, but the sheer logistics of getting all these tunnel segments built and out to sea in an orchestrated way. There isn't anywhere big enough to store them, so as soon as they're made, they've got to be taken straight out to sea.
To make sure nothing stops the production schedule once it's started, engineers have been practicing and honing nearly every step of the process.
I've now got the chance to get up close to a test segment that's been constructed. This behind me is just one of the rail tunnels from one end of a tunnel segment. And you can see when I'm standing in front of it, the immense scale of this project.
Well, this is our test bed where we are testing our production method, our forms, our crews, and of course the concrete that we're going to use to cast the tunnel elements. What we're actually building is not even 2 rail tunnels, not 1.5 rail tunnel here. The actual standard elements will be 42 meters wide, but it's big enough for us to experienced the scaling issues that are involved in building something like this. There's no instruction manual for building anything like this. You know, we are learning as we go, and we've learned a lot about the importance of communication between our crews and the way our concrete behaves over the casting period. And we're going to take all that know-how and make a few more minor scale casts before the real deal starts up at the end of the year.
What's being built here is proof of how construction is constantly learning and evolving. 30 years ago, when the Øresund Bridge was being planned, a tunnel like this wouldn't have been deemed feasible. The principles of this tunnel's construction are the same as any other tunnel from Sweden to Hong Kong, but our knowledge and skills have now advanced to a level where we can go deeper and further than ever before. When this tunnel completes in 2029, thousands of cars and hundreds of trains are going to pass through it every day. And that's going to be a game changer, not just for Denmark and Germany, but for the wider continent. But it all costs a lot of money, around 7.5 billion US dollars. $500 million of that is coming from EU subsidies, and the rest is coming from a loan underwritten by the Danish state. Crucially, Danish taxpayers won't have to spend a single penny. Now, the cost of the tunnel is going to be repaid over time by the revenue that comes from tolls on cars. It's likely that cars are going to be charged about the same as the ferry, about €100 to use the tunnel. And it's projected that Denmark could receive around $4 billion US in profit during the first 50 years of the tunnel's life. So, improving infrastructure, creating green travel corridors, and billions of dollars in profits. What could possibly be the problem?
It's not just the Fehmarn Belt's geography that this construction team have had to battle. Campaigners on the German side of the sea have fought tooth and nail for the last decade to prevent the construction of a permanent crossing.
I've been coming here as a child. It's the most sunniest spot in Germany, even if it's a little colder than in the south. It's one of the most sunniest spots in Germany, and up to now it's very silently. You've got a landscape, you've got the free ocean, you can go swimming, you can do water sports.
This is the downside of massive construction projects. Any new mega scheme has to be built somewhere, whether that's in a virgin forest in the middle of a city or on a quiet German holiday island. Whether you like it or not, it's going to have a massive impact.
They're destroying our nature. They're destroying the foundation for our economics, and they're destroying the foundation for ecologics we have here.
Some people worry about the impact this construction project will have on the unique ecosystem of the Fehmarn Belt. The marine life in this area of the Baltic Sea thrives on clear water conditions, and the concern is that digging the trench for the tunnel is going to disturb that.
Ecology of the Fehmarn Belt is very diverse. The clouding in the Fehmarn Belt will reduce the growth of macrophytes, of plankton, will have, of course, repercussions on all living fauna and marine flora.
Femern AS say sedimentation is one of the most closely monitored environmental impacts on this project. They say they use special dredging machines to minimise the spill and have patrol boats and monitoring stations around the dredging site to collect data on water clouding. This and other environmental data is published in real time on the Femern AS website in an attempt to improve transparency around the construction. But it's not just the marine environment that Hendrik and Isabel's organisation is concerned about.
A big feature that's being touted with this new tunnel is its ability to kind of create a green link with the continent. Femern AS say that because the distance between Hamburg and Copenhagen is being shortened, thousands of vehicles will have to drive 150 kilometres less. The new rail service will take cargo off of lorries and put it onto freight trains, and the new rail link will make taking the train a more attractive option. As well as wanting to improve freight connections, the Swedes are also very keen to avoid something called flystrike. Is that right? Flystrike. And pretty much want to make taking the train easier than flying as much as possible.
That idea is gaining traction. In April 2022, France banned all internal flights under 2 hours, and other countries are considering doing the same. If that's going to catch on, then good high-speed rail links like this are essential. But, and this is a big but, constructing something as ambitious as the Fehmarn Tunnel comes with a huge carbon footprint, mostly from the vast amounts of concrete being produced.
Only the prefabrication of this concrete tunnel will produce 2 million tons of carbon dioxide.
Fehmarn AS say that the Fehmarn Belt Tunnel is a generational investment in a greener and climate-friendly transport corridor in Europe. Once completed, the tunnel will deliver a significant contribution to the green trans-European traffic corridor by creating a 160-kilometre shortcut, creating a viable alternative to air traffic and shifting goods from trucks to electrified freight trains. They added that they're making a concerted effort to reduce the CO2 footprint of construction, but that it's not possible to build at this scale without causing some emissions. Just one of the initiatives is our commitment to use 100% renewable energy sources for construction and operations of the tunnel.
Fehmarn is beautiful and you should keep it like that, not changing it into a transport spot.
Inevitably, infrastructure comes into contact with the natural world. How couldn't it? That doesn't mean that concerns should just be brushed aside. It also doesn't mean that we should never build infrastructure ever again. What Isabel expresses are legitimate anxieties from people living on the doorstep of one of Europe's biggest construction projects.
When there is a good cause for a new mega project, it's important that project teams listen to concerns and work to reduce the impact of their work on people's lives and the environment as far as possible. That's something this project has set out to do from the start. Most of the construction activity is being done on the less populated Danish side of the water, and new habitats are being built to compensate for land now occupied by the factory.
Yeah, because it's going to take for a long time to build this.
Critics of the fixed link say that the whole project is speculative and that there's no way of definitively confirming whether or not it was worth the money. That's true, and it's the case with almost every other infrastructure mega project out there. The same was said about the Øresund bridge, and it's now a revered structure that millions of people rely on. Tourism is a big part of this island's economy, and it could take a hit during construction. But in the long run it could benefit from the improved connectivity. Over the next decade, a new route will be tattooed onto this part of the map, and for the people who use it, its convenience will quickly erase any memory of the enormous effort that it took to make it happen.
The bridge behind me is 60 years old and links the other side of Fehmarn with the German mainland. It was vehemently opposed when it was first constructed, but now with the construction of another new tunnel under this stretch of water, people are concerned for its future. They're worried it might fall into disuse or even disrepair. That for me is the story of modern infrastructure. Yes, these projects are difficult and controversial to realise when they're first constructed, but they go on to have a defining impact on all of our lives. The new tunnel under the Fehmarn Belt will impact millions of people across this continent over the decades to come. Any of the controversies around its construction will likely be forgotten, and the extraordinary engineering that went in will be taken for granted. That's all from me on the sunny island of Fehmarn. As always guys, if you enjoyed this video and you want to get more from the definitive video channel for construction, make sure you're subscribed to B1M.
Okay, yeah, there is pros and cons to things like this. Which side are you on? Are you pro infrastructure or pro preservation of the environment, right? I mean, if they can find a way to have both, that is where I stand. Because it's gonna help a lot of people, and at the same time we're trying to preserve, you know, how do you call this, nature-ish in a sense. It's really tough. It's really tough to kind of like find a balance. I know there are ways to do so, but I feel like the people want to just preserve it as it is, as it was, as it is, and like, don't F up the God created, you know, nature that we have with your engineering. I feel like that's what they want, which is fair, right? It's fair. But at the same time, with the growth of the economy and the population, there needs to be a balance. Unless we stop the growth of population and economy. I mean, that's the only way, right? To then not have to F up the creation, nature. But anyways, let me know your points and views in the comment section down below, and I will see you guys tomorrow. Bye.